Hello friends, welcome back to my YouTube channel. I can see lots of posts on the heat exchangers, so I thought of that quick sharing some of the checklist while designing the heat exchangers. Be careful that when you design internal heat exchangers, get it validated with the vendor who is supplying the heat exchangers because they have got their own priority softwares which they use it for their design and optimizing their design so that in future and during the operations there is no problem with the heat exchangers. So all the internal design need to be revalidated with the heat exchanger vendors. So since in line with my checklist video, this is the checklist on designing of the shell and tube heat exchangers and what are the criteria and what are the things that we have to take care while design. So let's quickly go through this checklist where we talk about that should be that your data sheets or the design template should have project number, project name, TMA type, heat duty, surface area mentioned, design margin on the area should be there, overall heat transfer coefficient should be mentioned, mean temperature difference should be mentioned, fluid shell and tube type should be mentioned, what is what in shell, what is there in tube, lance pressure drop should be given on the shell side, calculate tube side and shell side pressure drop should be mentioned. Then MOC of the shell and tube, like material of construction of the shell and tube, should be mentioned. Filing factors both for shell and tube should be mentioned. Then ensure that the standard pipe sizes have been used for shell ID before lining less or equal to 16 inches. Check with mechanical for ID to be taken. It should be yes. So you have to take care of these things. Check that all the process conditions are taken care in the output of the designed heat exchanger. Ensure the following that compatible with win number of baffles should be there. Nozzles on the same side is compatible with the odd number of baffles. Baffle spacing in the range of 20% to 100% of the shell diameter. Ensure that in-baffle spacing is adjusted to suit selected nozzle size. Ensure baffle cut orientation is properly selected. See yesterday help menu. Ensure that the standard tube lengths are taken in the nozzle location in heat exchanger as per the pin ID is the nozzle actual location, so it should match with the pin IDs. Okay, now allowable fractions for the very stream on the shell side are as follows, like B stream, which is the main cross flow stream with the bundle at least 0.6% for turbulent flow and at least 0.4 for the laminar flow. C stream, bundle to shell cross flow bypass stream. So these are the streams we can see in the STRI helpline or in the DQCon book as well. Normally it should be less than 0.1. A stream usually smaller than multi-sections baffle. E stream should be less than 0.15. F stream should not exceed 0.1. So note applicable only where the phase change, no phase change occurs. Use the following bundle and shell ID after lining where applicable. Radial clearance, that head type fixed tube, M type head, radial clearance should be 10 mm, U type 10 mm, S type rear head or P type rear head 30 to 22 mm should be their radial clearance. T type rear head like contact mechanical or the vendors for this this type. Then for the segmental waveform, are window flow or cross flow velocity near same? Yes or no? You have to put have to check this. Uh, for anti-IW baffles, is the ratio of velocity and the cross flow velocity between 2 and 3. Cooling water velocity in meter per second. If applicable, cooling water should be more or equal to 1 meter per second. Had the cell side pressure drop been optimized? Has tube side pressure been optimized? It should be checked, like when you design it, the heat exchangers. Is the ratio of nozzle pressure drop to total pressure drop not too high? For generally restrict the nozzle side pressure drop for both shell and tube to be 20% of the total. Tube side, shell side, you have to see that the ratio of nozzle pressure drop to the total pressure drop. You have to mention it as well. Whether the flow velocity of the shell and tube shall fall in the valid range. Has the requirement of impingement shell side plate or vapor belt been checked with respect to the nozzle? PEV square provide impingement plate for condensing vapor, which is like liquid flow limit nozzle PV square for up to 2000 lb per feet square or 3000 kg per meter second square. Boiling liquid 744. Gas, check the nozzle velocity is less than 20% of acoustic velocity. So these are for the nozzle design of the heat exchanger. Had the heat exchanger been checked for flow reduced by variation. Condenser, for the condenser STI uses resistance proportion method by default. For select other option, please use help menu. This is like when we go to the STI, these are the things we have to use for the condenser. Area ratio shall be in excess of 10% over the required area in all the cases except instructed otherwise. Check out the message displayed in the output of the exchanger design. This will help to improve the design further. So STI gives you warning and the messages also. So these are requirement. Mostly the message comes for the vibrations. I have seen that, and check that vapor curve data is properly entered and from the reliable sources for the vaporizers and condenser because there is a phase change. So these are some of the common checklist for the heat exchanger design, and hope you liked it, and do subscribe my channel and for more such process related information in the form of videos. Thanks a lot. Thanks for watching.